Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to the today's session on Milne Thompson method. In the previous session, we have discussed about analytic functions, analytic and harmonic functions, and the conditions to check whether the function is analytic or not, which are called CR conditions or CR equations. And also, we have solved some problems on analytic and harmonic functions. Now, in today's presentation, I would like to introduce a method called Milne Thompson method. And this method is used to construct an analytic function or to find an analytic function if either real or imaginary part is given or known to us. In general, the function f of z will be in the form u plus iv, where u is called the real part and v is called the imaginary part. Now, for example, we have only the real part of this analytic function. We don't have imaginary part v. Now, we can find the analytic function f of z, or we can construct the analytic function f of z just using this real part. Similarly, if only imaginary part is given, we can find the analytic function using the same. And that method is called Milne Thompson method. Now, first I would like to introduce the method, then I solve two problems on the same. Now, coming to this Milne Thompson method, let us consider an analytic function f of z in the form of u plus iv. Then the derivative of this f dash z can be calculated using this dou u by dou x plus dou u by dou x plus I into dou v by dou x. So here this is the partial derivative of u with respect to x and partial derivative of v with respect to x. So that means the derivative of this f is in the form of two partial derivatives of two functions u and v. Now, for example, if we have this f of z, an expression in terms of z, a function of z, then just by integrating we can find what is f of z. So we integrate this right hand side function with respect to z. That gives the required analytic function. So that's why we consider this f dash z, which can be calculated using dou u by dou x plus I into dou v by dou x. Now, we have CR equations. Here already our assumption is that this function f of z is analytic. So therefore, CR conditions will be satisfied. So using those CR conditions, dou u by dou x equal to dou v by dou y and dou v by dou x is minus dou u by dou y. Now, for example, we have only u, the real part. V is unknown. Then, here in the second term, we have dou v by dou x in f dash z. So, we can replace this term dou v by dou x using these CR conditions, and we can write this the same in terms of u. So, here you see the second condition, dou v by dou x is minus dou u by dou y. So, I can replace this dou v by dou x by this minus dou u by dou y. Then completely f dash z will be in terms of a single function u, which is the real part given in the problem. Then by integrating we can find the exact f of z. So, that is the actual thought behind this Milne Thompson method. So, we have the function f of z with only real part is known, let us suppose. Then f dash z we have in terms of u and v. Using CR equations, we can replace this dou v by dou x in terms of dou u by dou y, minus dou u by dou y. Similarly, if only v is given and u, the real part, is unknown, we replace the first term dou u by dou x using this dou u by dou y. So, if u is given, use the second condition. If v is given, use the first condition and replace the terms, corresponding terms in f dash z. So that's what given here. If only u is given, then use equation 3 in equation 1, or if only v is given, then use equation 2 in 1. In these both cases, we can find an expression for f of z, and if this expression is in terms of z, we can, by integrating, we can find f of z. So that means the f dash z must be in terms of z. So for that, the Milne Thompson method, by the Milne Thompson method, so this is the main point. Since f of z must be in terms of z, we replace x by z and y by 0. So replace x by z and y by 0 in the resultant function of f dash z, and then integrate to get f of z. So that is the Milne Thompson method. Here this is the basic calculations that we do, and here this is the main method of Milne Thompson method. So to write f dash z in terms of z, replace x by z and y by 0, then you will get f dash z in terms of completely, exclusively in terms of z. Then by integrating on both sides, we can calculate the exact analytical function. So here f of z, we need to calculate. What is f of z? Either u or v will be given. If u is given, v is unknown. If v is given, u is unknown. Then write f dash z as dou u by dou x plus I into dou v by dou x. If u is given, v is unknown, so we need to replace this term. If v is given, u is unknown, then replace this term using CR equations. So f dash z is some expression. Now this must be in terms of z. For that reason, replace x by z and y by 0. Then completely you will get f dash z in terms of z. Simply by integrating on both sides, we get f of z equal to some phi of z plus c. So this is the integration after integral value after integrating the right hand side, and plus c, the integral constant that we introduce. So this is the process of Milne Thompson method. Let us solve two problems on the same method. Now the first problem, find the most general analytic function whose real part is u equal to x square minus y square minus x. So here, given the real part u, x square minus y square minus x. Since u is given, let us find dou u by dou x, 2x minus 1. Here the derivative of x square with respect to x is 2x, for minus x it is minus 1, and y we treat y as constant, so it is 0. And also dou u by dou y with respect to y, then we treat x as constant, so first and third terms are constant, the derivative is 0, and finally minus 2y. Now let f dash z equal to dou u by dou x plus dou u I into dou v by dou x. Since v is not given, or we don't have that imaginary part v, we need to replace this dou v by dou x by some term in terms of u. For that, by using the CR equations. What are those CR equations? Dou u by dou x is dou v by dou y, and dou u by dou y is minus dou v by dou x. So here we need dou v by dou x. That means dou v by dou x is minus dou u by dou y. So let us replace the second term using this minus dou u by dou y. So dou u by dou x minus dou u by dou y with I. So this is dou u by dou x, we have 2x minus 1 minus I into dou u by dou y is minus 2y. So therefore f dash z equal to two x minus 1 plus I into 2y. Now to integrate this on both sides, the right hand side function must be in terms of z. So let us replace x by z and y by 0. Then what happens? F dash z equal to x by z, 2z minus 1 plus I into y is 0. So simply this is 2z minus 1. Now by integrating on both sides with respect to z, we get, so integral f dash z is dz, sorry, so we get integral df by dz is equal to integral 2z minus 1. So f dash z is df by dz. Since the integration and differentiation are the reverse processes, on LHS we get only f of z. These two will get cancelled. And this is equal to 2 into z square with respect to z. So 2 into z square by 2 minus integral dz is z. And after integrating, we get f of z, that is equal to 2 into z square by 2 minus integral dz is z plus c. Since integration and differentiation are the reverse processes, these two will gets cancelled and only f of z remains. So this is the required analytic function. If you want to find the imaginary part v, simply simplify this, use z equal to x plus psi y in this expression, simplify, separate the real and imaginary terms, you will get v of xy also. Similarly, let us discuss one more problem. Find an analytic function whose real part is, so it is given u equal to e power minus x sin y minus y cos y. So this whole topic, analytic function or harmonic function, depends on the finding the partial derivatives. So if you know how to find the partial derivatives, you can solve any given problem in this topic. Now again the real part is given, so let us find dou u by dou x and dou u by dou y first. So here, since x is present in both, here this, let us consider this is the first term and second term, so product of two terms. So we need to apply UV rule. So first function as it is. Now derivative of second function with respect to x. So sin y is constant. For x it is 1 minus, we treat y as constant, so 0. We need to apply UV rule here. So derivative of first function minus e power minus x into x sin y minus y cos y as it is. So here we get e power minus x sin y minus e power minus x x sin y plus e power minus x y cos y, and dou u by dou y. Let us find the partial derivative of u with respect to y. Then e power minus x is constant. Only we need to differentiate the second term. X is constant again, since we are differentiating with respect to x. So with respect to y. So x is constant and derivative of sin y is cos y minus, here we need to apply UV rule. Y into cos y derivative is minus sin y minus cos y into y derivative is 1. Now let us simplify this first. E power minus x cos y minus minus plus y sin y minus cos y. So these are the partial derivatives, and now we have the f dash z is dou u by dou x plus I into dou v by dou x. And since v is unknown, we need to replace this using CR equations. What are CR equations? Dou u by dou x will be dou v by dou y, and dou u by dou y will be minus dou v by dou x. So, by replacing the second term, we get dou u by dou x minus I into, here dou v by dou x is minus dou u by dou y, minus dou u by dou y. So, let us substitute these two. Therefore, f dash z equal to, first dou u by dou x e power minus x sin y minus e power minus x sin y plus e power minus x y cos y. This is the real term, real part, plus I into, so here we have minus of course, so this becomes minus dou u by dou y e power minus x cos y, e power minus x cos y plus y sin y minus cos y. Now, by Milne Thompson method, for the function f dash z to be in terms of z, replace x by z and y by 0. So, f dash z equal to x by z e power minus z sin y sin 0 minus e power minus z into sin 0 plus e power minus z 0 cos 0 minus I into e power minus z cos 0 plus 0 sin 0 minus cos 0. Let us simplify this. Sin 0 is 0. So, this term 0 and again this is 0. So, e power minus z into cos 0 is 1 minus here I into e power minus z. So, z e power minus z cos 0 is 1 minus 1. So, here in this dou u by dou y, e power minus x is common for all these. So, here we have brackets. Now, by substituting this in f dash z, we have this must be outside this e power minus z. Okay. Now, after simplifying, this is equal to, we know that sin 0 is 0. So, this term vanishes. Again here sin 0 sin y cos y. So, cos 0. So, this term into y is there. So, completely the first term is 0 minus I into e power minus z into cos 0 is 1. So, z minus 1. So, finally, f dash z is I into e power minus z into 1 minus z. So, f dash z is completely or exclusively in terms of z. By integrating, we can find the f of z. So, integrating on both sides with respect to z, we get LHS f of z I into integral of e power minus z dz minus integral of z into e power minus z dz. So, therefore, f of z equal to I into integral e power minus z dz minus integral z e power minus z dz. So, this is again here brackets we have. So I into integral e power minus z is minus e power minus z minus, here integral by parts. We apply integral by parts. First function integral of second, so e power minus z minus derivative of first, again integration of second. So this is I into minus e power minus z minus minus plus z e power minus z minus e power minus z. So I into z e power minus z minus 2 e power minus z. So I into e power minus z into z minus 2. So this is the required analytic function, and by replacing z by x plus iy, we can find the corresponding imaginary part also. So hence, using this Milne Thompson method, we can find the analytic function, or we can construct the analytic function if either only real part or only imaginary part is given. So in today's session, we have discussed about Milne Thompson method. So this method is used to construct an analytic function if the real part or the imaginary part, u or v, only one function is given or known to us. We can find, or we can construct this f of z in the form of u plus iv, which is an analytic function. So in the next session also we continue the same. We will solve some more problems on the same. So this is for today's session. Thank you very much.